Hi everyone, so welcome all to this second video on hydraulic turbines. So in this PPT or in this video, so what I am going to explain, what I am going to cover is one is impulse turbine, next one is a reaction turbine. So in the beginning, as I have told you that in the classification part, these hydraulic turbines are classified into two different types. One is impulse and next one is reaction turbine. Okay, so the example of this impulse turbine is Pelton wheel. So why it is called as this impulse turbine is because the water comes and hits the turbine blades in a tangential direction, and when it comes and hits the turbine blade, it will have some certain force, and it will come and hit the turbine blades within a fraction of a second. So there will be a combination of force and time. So the impulse, the force is nothing but force into time. So impulse force is created when water hits the turbine blades. Since that impulse force is created, it is called as impulse turbine. And the example is Pelton turbine, where so it will have impeller and it will have series of blades. So that you can see in this image that it's a huge impulse turbine which a shaft has got a series of number of buckets. You can see clearly in this image that the shape of the turbine blade. So this turbine blade is also called as a bucket because the shape of the bucket is a double hemispherical cup shape. That's why it is called as bucket or vanes or blades. Unlike reaction turbine blades, this is different in this Pelton turbine wheel. So how it is arranged is there will be two hemispherical cup are attached one after the other. So where water comes and hits in the middle portion of the turbine blade. So there will be a single shaft, and there can be a single impeller or there can be multiple impellers. So there is a huge component which are placed over there, and so water is used as a substance in this hydraulic turbine. And coming to this Pelton turbine, it is a tangential flow turbine. So this is very important as far as these turbines are concerned. So what kind of flow it is, whether it is a tangential flow or it is a radial flow or mixed flow. So this Pelton turbine is a tangential flow impulse turbine. So I told you how the impulse name is given to it, and the direction with which water comes and hits the turbine blade is in the tangential direction. So that is why this Pelton turbine is the tangential flow impulse turbine. Now coming to this head, this Pelton turbine is suitable for high head and low flow rate. So there it will be in the it will be greater heights when comparing to Kaplan turbine and Francis turbine. It will have more number of buckets or hemispherical cups arranged in a series way, and the flow rate will be very low when it compared to Francis and Kaplan turbine. So now coming to this energy available at the inlet of the turbine is only kinetic energy. So at the inlet of the turbine blade, when water comes and hits, it will have kinetic energy. So available energy which is at the inlet of the turbine is kinetic energy. And then pressure at the inlet and outlet is atmospheric pressure. So only atmospheric pressure will be taken in this Pelton turbine. Now in this image that you can see the parts of Pelton turbine. So there will be a casing which covers the other components, the internal components of the turbine, and it gives the housing effect where when water hits the turbine blades, it will control the splashing of the water, and the remaining water will be taken into tail race. So the casing will protect the water to flow out of the turbine. So it will give a housing effect. And what are the other components? The main components or parts of the Pelton turbine is one is penstock. Penstock is a channel through which water flows from the high level. Either it can be a overhead tank or it can be a container which is placed on the top of the building or some height away from the ground. So through which the channel through which water flows, that is nothing but penstock. And there will be a spear inside the penstock which lead to the nozzle. So nozzle is nothing but a small orifice through which with high velocity water comes out with low pressure, and that is jet of water coming out and hitting the turbine blades in the tangential direction. So here we can see that why this Pelton turbine is called as a tangential turbine is because the water comes and hits the turbine blades in a tangential direction. So that is why it is called as a tangential turbine. Next one, the remaining thing, the rotational part, so with which the turbine blades rotate is nothing but rotor. So all these rotor will be mounted on the shaft. There is a single shaft. The shaft will rotate. It will have a rotary motion, and on top of the shaft, this impeller or runner is fixed, and then the runner will have series of buckets. We call it as, or else we can call it as blades. And then there will be a brake nozzle where you can control the speed of the water which is coming out, and then outer part, so there will be a casing. If you look at the working principle of this Pelton turbine, so water starts flowing, so that potential energy will be converted into kinetic energy, and then that water will come and hit the turbine blades with some kinetic energy, and the energy which is available at the inlet of the turbine is a kinetic energy. And after hitting the turbine blades, this turbine rotates and shaft rotates. This shaft is connected to electrical generator which produces electricity. The remaining water, after splashing on the turbine blades or making the runner spin, so the remaining water will come and collected in the tail race, that is at the lower level of the turbine casing. So this is how the turbine works, the Pelton turbine works, and the different parts. Now moving on to this, the main parts, as I said, nozzle, there will be a nozzle and flow regulating arrangement. So nozzle is a small orifice through which water flows, and there is a runner and buckets. Runner is a wheel where it will have a rotary motion, and top of the runner there will be series of buckets are arranged, and there will be a casing which will control, or it will give a housing effect, so which will avoid the breakage of this. It will protect all the components getting exposed to outward area, and then there is a braking jet where, so we can control the flow of the water which is coming out from the jet. So these are the main parts of the Pelton wheel. Now coming to this radial flow reaction turbines. This radial flow. So reaction turbines is nothing but the turbine which acts as according to the reaction which is generated, produced, is nothing but reaction turbine. And the turbine which will have the radial, the flow will be in radial direction. So that kind of flow is nothing but radial flow. So that kind of turbine is called as radial flow reaction turbine. So radial flow reaction turbines are classified into two types. One is inward radial flow turbine, and next one is outward radial flow turbine. So this is based on the movement. So how it comes, where it comes from outward to inward or inward to outward. Based on that, the radial flow differs. So we will see in detail how what is the difference between this inward radial flow and outward radial flow turbines. You can see this first and foremost. We can see this radial flow reaction turbine. So where there is a water which comes through penstock. So water comes through this draft tube, and then it will come to spiral casing, and then water enters into the first runner. So there is a guide wheel. First there it enters into the rotor. So there is it is a stator. So water enters into the stator first. Stator is nothing but a guide blade, or it acts as a nozzle, or it is also called as fixed blade. Okay, so after passing through the fixed blade, the water enters into the guide blades, and then this guide blade will rotate. So this guide blade, moving blade will rotate, so it will have a rotary motion. This moving blade will be mounted over the shaft. So this is the working principle of this radial flow reaction turbine. So we can see it is clearly the different parts of this particular turbine in this image. Next, move on to this. If the water flows from outward to inward, the turbine is known as inward flow, radial flow turbine. So water from outward direction to towards the inside, at the center of the turbine, inwardly. So that is called the inward radial flow turbine. Or if the water flows from inward to outward, the turbine is known as outward radial flow turbine. So now what are the main parts of radial flow reaction turbine is? One is casing, one is guide mechanism, next one is runner, and next one is draft tube. So here we can see the inward flow reaction turbine in this picture. So where we can, so water enters from outside and then it will flows at the center towards inwardly. So that is nothing but inward flow reaction turbine. Moving blades are there, guide blades are there. Through guide blades, so water enters towards the center. So that is nothing but inward flow reaction turbine. If the water flows from outward to inward, the turbine is known as inward flow turbine. So, water will consist of guide vanes which directs the water to enter the runner. The outer diameter of the runner is inlet and the inner diameter is outlet. So here in this outward radial flow turbine, we can see water from center, it goes out, moves out. So that is how it goes outwardly. That is nothing but outward flow radial turbine. So it is clearly given. When the water flows from inward to outward, the turbine is known as outward radial flow turbine. The inner diameter of the runner is inlet and outer diameter is outlet. So this is all about the different types of turbines. Okay, in my next videos we will see the other concepts. Thank you for watching this video.